Alright, this is Chapter 3, Section 3. We're going over the formal rules of probability now. So in the prior sections we went through independence, dependence, mutual exclusivity, not mutually exclusive basically. So now we're going to formally define the rules that revolve around those. So first is multiplication. So multiplication is when you're talking about independence essentially. So A and B essentially means that both of them happened. So both A and B happened essentially. But you have to consider conditional probability, which is, does the second or third thing rely on the first thing, or the ones that came before it essentially, right? So do I have to worry about the thing that already occurred essentially is what we are concerned about. So what it comes down to is and is a multiplication type scenario. Whenever you have the and, whether it's explicit or implicitly said, it's multiplication. So it's either intuitive or non-intuitive. Okay? If it's intuitive, you can just shut your brain off and multiply the probabilities. Whether they're fractions or decimals, multiply them, call it a day, because they're unrelated, right? They're independent events. However, if it's non-intuitive, you have to worry about all the other probabilities after the first one because they depend on the prior ones. As to how they depend, it's going to vary because there are infinite ways things can depend on each other essentially. Okay, so independence and dependence has to do with the multiplication rules of and essentially, right? So there is 3 ways to prove independence, which we did previously, right? If they're independent, you can use any one of the 3 ways to prove it. You're good. Just multiply, call it a day. Otherwise, there's dependence, and there's infinite ways to be dependent, and you'll have to figure out what those are given the scenario, and then multiply each successive one after that by modifying the probabilities. Okay. So addition has to do with the or cases, right? So remember, we have to remember what or actually means. It's the one event A occurs or event B occurs, but they can also both occur, right? That's fine for or, right? So you want a car with leather or a sunroof, but if you get a car with both, you're still good, right? So that's the or. So these are also intuitive or non-intuitive essentially. So if it's intuitive, right, you can be 2 of the same things at the same time. Or not 2 things at the same time, or if it's non-intuitive, you can be the same thing at the same time. So what does that actually mean, right? So I'm mutually exclusive, which means I'm either A or B. I'm apples or bananas. Or I am not an apple. Crap, let me just erase that. Or I am not an apple, and I am not a banana, right? So either way, it's 100% of all fruits, right? Apple, banana, neither, right? Which is the outside, which is 100% of all fruits. So all you have to do essentially is add up the apples, add up the bananas, call it a day, right? So if it's not mutually exclusive, you're going to have things in common. So like A and B, right? Okay. So this could be like, I don't know, what's a good example? Cars with sunroof, right? You can be a car, right? So this area right over here would be the probability. We'll say A is a car, right? Car and no sunroof, right? This over here, right? This will be the probability of a sunroof. And not a car. Maybe that's not a good example. I don't know. Let's think of something else here. Right? And then, of course, out here is the probability of not being either, right? Okay. All right. How about this as an example? Right? We'll do tall and good looking. How's that? Right? So this one right here is tall and not good looking, right? This one right here is good looking but not tall. And then outside here is neither, basically. And then inside is both, correct? All right, so you have A and B, but the problem is if you add up all of A and you add up all of B, you end up adding the center together, right? So therefore you have to subtract out the overlap, which is the AND case, right? Okay, so essentially intuitively or non-intuitively. If it's in the mutually exclusive, well, it's intuitive, just add, right? The fractions of the decimals, call it a day. If it's non-intuitive, you have to figure out what that overlap is. You have to do a little bit of work and turn your brain on for it, essentially. Okay, so let's look at the next ones here. So let's say Klaus is going to choose to go on vacation, either New Zealand or Alaska, and the probabilities here are given. Well, you can't go to both places at the same time. That's not possible, right? So that's just going to be 0, right? So that's because they're mutually exclusive, right? You cannot be both at the same time, right? So or is when you add them together, right? Or is the add cases. So if that means all I have to do is add them. Add this plus this, and then subtract out the overlap. Okay. Well, if I do that, that's going to be 95, correct? Okay. So we know my and is 0, and then the overall is 95. You're like, well, that's not 100. Well, that's fine, because what if you didn't go on vacation? That'd be the last 5%, correct? Okay. So let's look at the remainder ones here. Let's say a certain player scores a goal of 65%, right? Okay, so let's shrink this down. All right. And if the player makes the first shot, then the player goes in a streak and has a 90% chance of making the second shot. If the player makes 2 shots on goal, determine the if the player makes 2 shots on goal, determine the following. We don't actually need this part. So let A be the event of making a successful attempt on the first shot, and let B be the event of making the successful attempt on the second shot. Okay, so we want the probability of A and the probability of B, correct? Okay, so I'll make this blue, format, color, blue. Alright, so this is the probability of A times the probability of B, probability of B, right? Because and is multiply or is add, right? But the problem is this second shot is conditioned on the first shot, right? Conditional. So it's actually a conditional one, which means this is a dependent scenario, correct? So therefore, we have to do the 0.65 times the 0.90, right? So that would be 0.585 because they are dependent events. Correct? All right. Okay. So the one that makes the first goal or the second goal. All right. So let's we'll just make a new one. This is the probability of A or B, right? Or B. Okay. So that would be the probability of A plus the probability of B. But remember, in addition scenarios, you have to subtract out the overlap because you don't want to count twice, right? And it's a question of, at this point, is there an overlap? Okay, well, let's just make that blue, right? Because if there's an overlap, that means you can be both at the same time. Well, we already proved that. You can be both at the same time, right? All right, so you can be both. All right, so this equals 0.65 and 0.65. Assume the events are independent, and then the overlap is 0.585, which accounts for the hot streak, so that's 0.715, right? So they are not mutually exclusive. Okay. All right. So that's why we have to subtract out the overlap, because they can't be the same thing at the same time. Right, and they're not, and they are dependent because the next one depends on the previous one, essentially. Okay, so what do we have here? Probably player misses both goals. Okay, so that would be the probability of A times. Let's actually put the little bar above it, and then we'll put the multiply, and we'll copy. All right, so why is it A twice? Well, if you miss the first one, it's like starting over, right? There we go. It's like starting over. Okay. So it's essentially starting over and get A again. So if you miss a shot, making 65, so missing is 35, obviously. Okay. So there's no streak at all. So that would be 0.125. Those are independent, right? Because once you miss, it does not have any bearing on the next one, essentially, right? Events. Events. There we go. Okay. All right. Are A and B independent? Well, no. We just proved they were dependent, correct? So essentially, the multiplication of them does not equal that, right? Because you just multiply A times B to get 65 times 65, which is not this, essentially, right? That's not true. Are they mutually exclusive? No, because the overlap is clearly not 0. It was 585, wasn't it? So that is clearly not true. Okay, that's the end of the first part.